and how that works. But we have a former professor for the military, if you will, so again, this will be the master class of this. And I'll hand it off to you.
My name is Rimmel Spencer. My call sign is KA6DOY. I got licensed in 1978. I'm a life member of the ARRL. I'm a member of the TARC and also the TRO Club. So I'm excited about HF. I always have been, and I hope you will be too when we get done here. Everybody in here will be able to build an antenna of some sort. So we're going to get started right now. And the first, that's page 2. Yeah. I noticed whenever we got these slides made up that they weren't in order. So, yeah. Okay. We're going to ignore those for right now. We still need page 1 up there. We're concerned primarily with the spectrum 1.6 to 50 megahertz. And I'm going to put some numbers on the board here. This is going to come at you kind of fast, but it's got to be that way. There's a lot of information here. Can everybody see that?
Yes.
All right. So those are important numbers. If you don't remember anything from today, remember at least one of these numbers, because this is for a full wave antenna. This is for a half wave antenna. And over here we have our quarter wave. For HF, you're probably not going to use that. This is going to be your main length here. But if you remember this, full wave, then you know you divide it by 2 and you get the half wave. So that's what we're going to do right now. And let's see here. I think we're just out of sync on those.
Page 2 is the first page I got in this file called antenna.
Okay, so we need an eraser.
Over here.
The trusty paper towel. Always a good eraser.
So who remembers what the half wave number was up there? 468. We're going to use it right now. And if somebody will do the math on your phone, I'd appreciate it. We're going to build an antenna for 7.2 megahertz in the 40 meter band. So if somebody will do that and tell me what you get. 65 feet. So that's what we've got for our half wave antenna. And since this is a perfect dipole antenna, we're going to come up here and we're going to put a 1-to-1 balun up there. It'll look like any of these, either one of these. This is a 1-to-1, I don't know what that is, but it can look like that or that. And then we're going to take this length, 65 feet, and divide it by 2. What's that come out to be? 32 and a half. So we're going to hang some wire out here. 32.5 feet, even on each side. That's why this can be a 1-to-1 balun. And when you get your balun, if you're only using the power out of your radio, then you only need 100 watts, basically. Then, now that we've got our wire up there, we need some insulators. They can be plastic, porcelain, any non-conducting material. So there's our insulators. Then we're going to use a non-conducting rope and tie that off. That's our coax connector. So we got to feed it, and we're going to feed it with coax. Now when we do that, some people say you want to put a coil of wire up here. That's to keep RF from coming back down into your shack. What you can also use are ferrite beads. And you can get these in various sizes for different coax, or even use inside your shack. But they're kind of heavy. So all you do, if you're not going to coil the wire, and would be 6 turns, 6 to 10 turns, about 6 inches of wire. That keeps the RF from coming back down into your shack. Otherwise, use a ferrite bead. So, any questions so far?
Where do you put the ferrite bead?
You would put it right up next to the connector on the end of your coax going into your balun. So the coax would connect here, and right about that far down I would have the ferrite beads. Anybody else with a question? Okay. A common mode filter.
That's kind of like a one-to-one.
Yeah, of course, yeah.
We'll also keep it RF isolator.
Yeah, well, you know, I want to operate on more than one band. So I'm going to turn that into a multi-band dipole. And this is how I'm going to do it. Well, we know this is for 40 meters. So once again, put my insulators out here, tie them off. But then I got to figure out how long that wire is. So if it's for 20 meters, we're going to take our 468, divide it by 14.3, we'll say. Or no, I can't do that. 14.2. And so what do you get when you do that? Anybody? Hey, thanks. We'll call it 32.9. So then we're going to divide that by 2 and we're going to get 16.45. So this wire is going to be 16 and a half feet roughly. Same over here. So we've got a 2-band. Well, now I want to operate on 10 meters. Once again, we're going to hang another wire out here, etc. Any questions? Okay. Now, if we wanted to operate 80 meters, we would follow the same formula and just figure out the length, divide it by 2. So we're going to have our 80 meter wires coming out. So that's a multi-band dipole.
Am I using the same balun for this?
Yeah. In fact, I don't know where the lid to this thing went. It's probably going to dry out. But you could also just use that. I used to make these. You pour them in a little Dixie cup, put your wires coming out and everything. So that's just a center insulator, acts as a 1-to-1 balun. There is no matching there. So we could hang this guy up here with all those wires. These are $15 at any ham fest, just about.
On the wires, could you actually take one and fold it up to where it started 20 meters, and then maybe you unravel more wires, like you have it all wrapped up, where you unravel enough for the 20
Yeah, they make an antenna like that commercially, I believe. I don't remember what it's called, but it's like just on little pulleys, you pull it out. So, anybody else? All right.
Of the one-to-one baling in this example?
What is the purpose of it?
Yeah.
It's joining your coax and your wires. The question was, what is the purpose of the center insulator? So you feed it with your coax at the center insulator. That little guy has got a PL259 connector in there, so you feed it that way. And then it gathers your wire or your wires. So you'll notice that this one has a little ring at the top. That would be handy for pulling it up into something. This doesn't, but these are good for, well, anything you need a one-to-one on. So, any more questions? Yeah.
Getting back to the ferrite, excuse me, getting back to the ferrite beads, how many should you use? Is one enough or do you need more?
Well, you may need more. You know, I think one of my loop antennas, I have 2 on, so we need to move on here. So I'm going to build another antenna. This time we're going to use a 4-to-1 baling. So this little guy, although he's not labeled, is a 4-to-1 rated at 300 watts. This is also a 4-to-1 rated at 1200 watts. So you see they come in various sizes. But anyway, we're building an end-fed now. So we're going to use this guy, 4-to-1. So we're going to coax feed it. Then we're going to take our wire out here, probably about 90 feet. Radio likes a lot of wire. Put our egg insulator out here. And so we're going to radiate that antenna. Is it going to work? Yeah, it's going to work. But what could we do to make it work better? Well, I used this antenna. I liked it a lot. Then I thought, I'm going to go ahead and add this ground out here, see what happens. It worked better. Well, then I got curious again. I thought, that ground wire is just about the same size of wire as I need for another antenna. So this is an end-fed. Any questions? We're going to turn that end-fed I picked my ground wire up. I put an egg insulator on the end of it, ran it to a tree. I now have an OCF antenna. It's also called a Wyndham. The formula for this, on one side, you want 1/3 of the wavelength of your frequency. On this side, 2/3. So we have just built an off-center fed or a Wyndham antenna. I know this is boring stuff, but go ahead.
I think it's fascinating personally. I have a question though, 2 questions. One, when would you choose one over the other? And that may be opening up a can of worms. So.
No, that's a good question.
2, do these all have to be in a vertical or a horizontal configuration, or can I manipulate them?
You can manipulate them, any way you want them. I'm actually using one of these. The center part is up about 20 feet. This part's up about 35. This part's up about 30. So it actually, slopes down from that end. When you're getting your coax, if you're not real familiar with putting, yes sir?
What's the advantage of that other than the other antenna?
More wire. More wire, more gain. Okay? Because without this part, then whatever signal you're going to pick up over here, you're not going to get. And let me tell you, there are some tips and tricks to ham radio that some people aren't aware of, I guess. In the military, we were taught no SWR, period. Get rid of all of it. Because if you've got a 500 watt transmitter and you have no SWR, chances are you're going to have a good signal of 500 watts going out. There'll be some losses, but. So we have just built an off-center fed. Yes, sir.
I'm still fuzzy on why this Balin is a 4-to-1 as an off-center fed antenna with a dipole, which is equidistant on either side, was just a 1-to-1. What's going on in that Balin right there?
Well, I can explain it better this way, I think. This is our 1-to-1. These wires are equal. That is a balanced antenna. Because if we were to break our coax out and feed it, we could feed it like that too. And have a jumper coming over here like this, feeding it. So this is a 1-to-1 fed like this. It's a 1-to-1 fed with a 1-to-1 Balin. It's always going to be a 1-to-1. Now you could use a 4-to-1, but it would be kind of a waste. Why put something on there that the benefit is better used with an off-center fed?
Would your SWR be equal on both 1-to-1 and 4-to-1?
No, sir. Yeah, that's a good question. You're going to find that the perfect antenna is out there in outer space. It is a perfect resonant wire. It has no encumbrances to interfere. That is the perfect antenna. We're never going to get that antenna here on Earth here. So every antenna is a compromise. And it doesn't matter what it is. Every antenna is a compromise because you can't achieve the free wire in space. So, any more questions right now? Yes, sir.
What does that mean, 4-to-1?
This is a 50 ohm load coming in here. Okay, so if this works out to be more than a 50 ohm load, then it's an imbalance. That can cause increased SWR, a lot of issues. But with the 4-to-1, it will accept the imbalance and make it balance as far as the electronics of the circuit and the radio are concerned. Okay?
What is the impedance on the wire on the other side? Is it 200 ohm? Or what is it?
What is the
What is the impedance on the wire on the other side? If you're 50 ohm, where you're coming from the transmitter, what's your impedance on the wire on the other side?
That's a good question. Beyond the scope of this presentation. Okay. All right. I want to show you something here. 4-to-1, 200 ohms, 50 to 200 ohms. 9-to-1, 50 to 450 ohms. But the physical size is really small. That's a 1-to-9. This is also 450 ohms. But you have to have the exact length. Where you commonly see this is on the G5RV antenna. And I'll mention to you right now, these are two 80-meter antennas, a G5RV and a dipole. I bought both of these at Shulman Auction in Kansas City for less than $100 with shipping. Keep that in mind. This is about a $150 antenna right here. So if there are no questions, how are we doing on time? All right, we want to build a loop antenna. Is everybody okay so far with this?
Can I ask one last question?
You bet.
Why is it important to match wattage when you're selecting your balun?
It's a good question. I have 2 of these that got power into them. One of them, it took out the corner, just broke it right out. Too much power, so that's the importance. Now, these are really nice baluns. They do a 4-to-1 and a 9-to-1 at 1200 watts. And we're gonna use this right now. Everybody okay? This is made by Palomar, and as mentioned by Mark, these are available at HRO in Texas. So one thing you'll know about the off-center fed antenna, it is a quieter antenna than a standard dipole. And so on some of the bands, it really makes a difference. So we want to build a loop antenna. I'm going to use this guy right here. He's labeled 4-to-1 over here, 9-to-1 on top, and ground over here. Now you can get these with a 4-to-1 like this. And this is what I like instead of that design. It's just personal preference. So first thing we need to do is find out how long of a wire we need for a loop. Loops are generally full wave antennas. I'm a little hoarse. I've gotten over COVID recently. But so we're going to use this number, 936. We're going to build an 80-meter loop antenna for 3.8 megahertz. So could somebody do the math and tell me how long that is?
That's a number.
Yeah. What is it?
246.3.
246.
Homeowner associations do not like that number.
Yeah. So we've got a nice tree over here. We're gonna stick our 4-to-1 balun right there. Over here, we've got another nice tree. We're gonna tie a rope up there, put a snap hook on it, and have our wire connecting to our porcelain insulator right there. Over here we don't have a tree. So we're going to get a piece of pipe or a mast, a collapsible mast. I used a piece of top rail, 10-foot top rail. On top of that I put a piece of 10-foot PVC. You'll know why here in a minute. So that's what I'm putting right there, that pole. Over here, I need to do the same thing, but I had these nasty old power lines there. But when you use the PVC, what you get is you get a straight piece of pipe, and then you get an angle like that. So they angled in just enough under those power lines. So over here, we're going to pick up our wire on one of these terminals, okay, on our 4-to-1. We're going to run it over to this snap ring, to our glass insulator, over to here, over to here, over to here. Now I'm going to tell you, I screwed this up when I made this antenna. And I had heard everybody talking about how quiet the loop antenna was. And I thought, well, why isn't mine quiet? Because I had an open circuit here. I needed to bring that wire right up to that other terminal. When I did that, the noise went away, the antenna tuned up better, and it worked much better. Now I'll tell you, how long is this wire? I question this number here. Is that right, 246? Okay. So what we're going to do is we're going to take a quarter wave here, etc. So we're going to have equal distance. But I can tell you that's going to be a puny loop. Typically, that's what you want to shoot for. Now there's a guy out in New Mexico, he has a 1,600-foot loop running over arroyos and everything else. I mean, it's a monster. So that's our loop. How we do it on time. Cool. Any questions about putting up a loop? Yes, sir.
Because you were so close to those power lines, did you have any interference?
I did initially. I don't notice it now. Whenever I got this right, that took care of the noise over there. And by having that PVC angle that in just enough, it was far enough away from the power lines it didn't bother it. Anybody else with a question?
Just a quick review.
Yes, sir.
What were the safety measures that you used when you were getting close to those power lines?
That's a good question. We were in the Philippines and we were working on a 35-foot whip on a carrier. There was a storm about, we could see it 20 miles away. And we couldn't stop. We had to get this antenna finished. And all of a sudden there was a lightning strike over there. One of the guys felt it on that antenna we were working on. So, what was your question again?
Great story. Thank you for sharing.
You're welcome.
But when you are starting to play with antennas that are off the ground near power lines,
Okay.
what's the safety? Why is it so important to pay attention to that?
Well, it depends on what the voltage is in the power line. It could arc across, okay, if you have metal. But I only took the metal up 10 feet. All this is non-conducting material. So it was pretty much a moot point with that. But yeah, you do want, anytime you have power lines, you got to be very, very careful working around power lines. Any more questions? Yes, sir.
So this isn't a full wave or half wave off the ground, but how high off the ground? I mean, what kind of problems would the ground interference cause, seeing how you're not
It's a very good question.
wave off the ground?
Right. They say that you want this up 45 feet. Now, my little loop I have up is only up 25 feet. What you're going to find, if you don't get, and we can't get the perfect antenna, everything we do with the antennas is a compromise. Because we'll never achieve the ideal. We're going to strive for it. We want our SWR to be 0. And we'll talk about that in a minute. But I want to show you how to build a delta loop. Okay, now these don't have to be big antennas. I know people right now that are using, in an HOA, an antenna mounted on their 6-foot fence. It's a, yes sir?
What type of wire are you using for the loop?
Oh, that's a good question, yeah. I wouldn't use this. This is like magnet wire. So I wouldn't use that. See what this one is. Okay, this is antenna wire. And we'll have all this stuff set out here But the antenna wire here, for this antenna is actually a multi-strand copper. So that's probably a lot more durable than this stuff that looks like magnet wire. So, but myself, every antenna I build is built with 14 gauge solid copper conductor wire. Never had one break. Any more questions?
You can get that coated too, right?
Co-
14 gauge, coated, black, if you're worried about aesthetics.
Oh, well, I always get black wire, so yeah, so yeah, I've thought about that. How could you hide a wire? Yeah, I have heard of people doing 22 gauge antennas, and that kind of hides them, especially if you do an in-fed where you're, putting your matchbox down here and, running that up to a 6-foot fence or something. Nobody's going to see that. So, yes, sir.
Is it correct to state that, in-feds dipoles, they can all work in any configuration as long as you're not doing 90-degree bends in the wire?
Well, that's a good question. And, with this G5RV, it's fed with this stuff here, ladder line, that I've never really enjoyed at all. But it's 120 feet long. And if you had to, you can bend it. Say you could only get 40 feet out, this way, you could bend that thing. It's a compromise. You're on the air. This fellow that I know down in Katy, Texas, he has a multi-band antenna with on his 6-foot fence with a remote antenna tuner out there, and he works the world. He runs Legal Limit, and it handles it. I personally, I can't believe it works, but it does. So are you guys ready to talk about a Delta antenna? Yes, sir.
Speaking of hooking up antennas on fences, with things like barbed wire and pipe fences, having your antenna hooked up onto it, would it cause any sort of parasitic or reflection issues with the antenna actually being on the fence, seeing how, metal near metal?
Oh, yeah, I would think so, yeah. One thing we're not going to talk about today is harmonics and the different orders of harmonics, but that might be something that you would get into with that. So, any more questions?
25 minutes from
Okay. Do you all feel like you're getting something out of this?
Oh, yeah.
Okay. We got one more antenna to talk about here, and that is the Delta Loop. Mr. 4-to-1 there, they like these to be fed at the top. And anyway, maybe that's why the notes didn't work, because I drew the picture so it was fed from the side. I don't know. But once again, we're going to take our, got our glass insulators here, and we're going to run our wire to our different anchor points using snap rings and rope to tie them off to a tree or whatever. And so what I've done, I've got some notes here. This is for a, let me see here. Okay, this is for a 40-meter Delta Loop. So I've done the math here. And this is going to be 23.3 feet. So those are equal distance, 23.3. Except for this one down here, they say he's 23.4. Oh, excuse me. Yeah, that's right. 23.4 to 23.6. So that's a Delta Loop. You feed it with your coax up here, and that's all there is to it. The main thing with these antennas, get yourself an antenna book. I am not an antenna expert, although I have played with antennas aboard ships and all over the world and in my ham shacks, but I'm not an expert. I never will be. These books will definitely keep me on the right track. All the antennas that we've talked about so far are in these books. And if you get lucky like I do, I bought this at a ham fest. Even had the CD in it. When I got it home, I found out it was the library book. So, you know. But anyway, this is a G5 RV. This is a multi-band antenna, good antenna. This is just an 80-meter dipole. Now, you can use that on all bands, but you're going to need a tuner, what Mark was talking about there. So any questions so far?
On your notes, that's a 20.
Oh, okay. Well, I don't do good notes, I guess. Thank you. Yes, sir.
In the antenna books, you got suggestions for a specific one that's got better information, references?
Well, you know, this one from the ARRL is really a good book, I'm finding out, because you know, it's so big for one thing, but they really go into great detail. And all of these antennas will be in these books. When I go to Hamfest, you know, if I see somebody throwing away QSTs, I grab them because there's going to be something in there I've missed or need to review, and I can give that to another fellow wanting to get his ham ticket. There's one more antenna we want to go over here. But before we do that, we're going to go ahead and talk about these balins again. Pay attention to the power, okay? Look at your, look online, Google the antenna you want to build. See if it requires a 1-to-1, a 4-to-1, how much power are you running? You know, if you're only running 100 watts, don't go buy a 1200 watt or a 5 kW balun. You just don't need it. Huh?
Could you use one if you're only have 100 watts?
You could indeed. Yeah, it'd be a little overkill. But yeah, you sure could. Yeah. So all right, now if you need a bigger balun than this, High Power Antenna Company. The gentleman makes these, all of his baluns in 5 kW format. So all right, I want to talk to you real quick about trap verticals, because this is something that really confuses me, did for years, until I got busy and studied it the other night. No, these are the trap verticals. There's one in particular sold in the UK. It's called a X80. It's an all band, and it's not a trap vertical, but it has a, I think it's a 4-to-1 down here, and it's a 17-foot antenna fed with coax. You don't have to have radials out, but you could, okay? The radials are just going to improve performance. All right, so we're going to do our trap vertical here real quick. Okay. I think I have this example in the notes that I wanted to pass out today. But this is a trap vertical antenna. It's fed down at the bottom of it with coax. And there's also a picture in the handout showing how long these ground radials could be. And that's why I included this, because a lot of people wonder, like myself, how long do those ground radials need to be? In the handout that's available in our notes online, you'll find that. that page right there, and it'll tell you how long they have to be. But do you know what a trap vertical antenna is? Okay. A trap vertical antenna is a multi-band antenna, and I'm trying to think, I believe there's quite a few of them. Atlas makes one, I can't remember. Everybody makes a trap vertical. So the way this thing is set up is you've got these traps. They look kind of like this, okay, but they're metal. And so you got your aluminum pipe here, your trap, aluminum, trap, aluminum, trap, aluminum. What is happening? The RF signal is coming in. We're operating 20 meters right now. That signal is coming into the antenna. It's stopping right there. That trap does not let that 20-meter signal go past it. Then, all right, well, we're going to go to 10 meters. But you'll notice that part of the antenna, okay? So we're going to go operate 10 meters. So the 10-meter signal comes in up here, goes right through the trap, and look at that. He uses that part. Any questions about this? Yes, sir.
I think your 10-meter trap needs to be on the bottom.
I was wondering if you would notice that. That's exactly right. It's this thing. This is what did it, Rob.
Get that Manacoozie.
But you might remember that. You might remember Rimmel standing up here and telling you this, and Rob pointing out that, hey, that's not right. That's a good thing if you do that, because then that's locked in your mind there. And you know, just like 468 feet for the half-wave antenna, that gets locked in your mind. And you know, all right, beam antennas. In the handouts, there are some couple of pages about beam antennas. The things you want to pay attention to with beam antennas, of course, you want to get one that's got the best gain. All right. Then you also want to make sure you want to check the wind loading. You don't want an antenna that has a real light wind loading, because then if you put a 50-pound antenna up there, it could get blown over, you know. And so you also want to pay attention to your boom length, okay, and your longest element length. They'll also give you a turning radius, and that's important too. So if you buy a full-size beam antenna, it's going to have a bigger turning radius than, say, what is that thing called? A Mosley Mini 32A, which is a 2-element beam. It's a great beam to start off with. It's only got 2 elements. It's mast mounted or tower mounted. A lot of fun. Any questions? Yes, sir.
How do the traps work? Are they similar to a loading coil, or how do they work?
Exactly. That's what they are. What they'll have inside of here, of course, they won't have this hardware on here, and they'll be aluminum. But they'll have a coil of wire down here that'll come up so far, and it's going to quit. And then they'll have another coil of wire going the other way, and it's going to go up to the next trap in sequence. So, real briefly, when you're working on your antennas, use an antioxidant compound. Get yourself this marine heat shrink. It's got glue in it, so you won't get the moisture. They also make various tapes and things like that. Usually I use the tape, and then you can get some liquid tape, which adds a little more protection to your connections and stuff like that. And when you're putting your antenna up, use a good grade of rope to hold off your, well, we don't have the picture there, to hold off your various insulators and stuff. So, anybody else with a question? Yes, sir.
Going back to the end-fed cascade dipole, sometimes I've heard or read that the length of the feed line makes a difference. Is that true? Or is that just a wide statement?
Well, I tell you, I haven't had that issue. I haven't run across that reference. Now, when you buy this balun on the end fed and you hook this up as an end fed, you're going to get instructions that are going to have like 50 different cable lengths to avoid. Forget it. Just forget all about that, you know? Just put your wire up. If it doesn't work, trim it or tune it with a tuner. And
The next end-fed question, you showed one with and without a counterpole.
yes, sir.
Okay, so that, if that end-fed, if the connector is up here and it's terminated at a tree out here, that counterpoise can just run straight down?
Sure
like a
can.
triangle? And does it have to be a certain length?
Well, the length of the counterpoise will be determined by the height of the antenna. Now, ideally, they want you to have that up about 40, 45 feet. But in my situation, I can't do that. So mine is up about 20, 25 feet. So the counterpoise runs down to a ground rod in the ground, and that's it. But I did add the wire to make it an off-center fed. And I also put up 2 end feds and bought a phasing cable, but it didn't work. So I encourage you guys to experiment. And I'm going to draw a quick antenna up here. All right, this is coax. This is a coax made antenna. I always do that. Up there, we're going to do that. Let me make sure I got my, oh, I don't have the notes. Okay, that's all right. Down here, we're going to take this and run it over to here. We're going to put a little capacitor here. We're going to run that up to there. This is an 800 to 1,000 picofarad. This is about a 6 to an 8 foot loop of RG58 coax. Real easy stuff to work with. So I don't know if that works or not. But maybe one of you guys will be able to help us next time we get together. And so that's a real good receiving antenna, I think. But let me do this real quick again. All right, so there's our coax. And these are just simple, easy receive antennas that you can play with. And this gives you tuning down here. This little capacitor, it's only a little bitty thing, but you can tune it with a tweaker. The difference here in these antennas is that up here we went center conductor to center conductor. Now we're going center conductor to shield in both cases, and down here we're going center conductor through our capacitor, and that's how we're accomplishing our tuning.
Where do you hook the feed to the radio?
Well, you're not. This is a receive only.
Well, you gotta have it.
Well, I know. Of course, you're either going to have to wire this. I would probably use alligator clips, you know, because I want to use this on different radios. This is not something that you're going to use on a, you know.
So your capacitor is shorted between, or not shorted.
Yes.
Connected between the two that goes to.
Yeah, and you know, you could have alligator clips. You could put a PL 259 on there. You know, in the notes,
You said it was a receive only?
receive only, yes, sir. All right, we're just about finished. I've got one more thing I want to point out to you, and you'll see this in the notes if you can print those out or get a copy of them. Oklahoma used to have a,
For all your 10 minutes, so that's fine.
I only need 2, I think. Oklahoma used to have a great antenna company. It was called the Hornet Antenna Company in Duncan, Oklahoma. They made HF beams, they made everything. They were bought by Swan Electronics, who was bought by Cubic, who put the people in Duncan out of business. So if you see one of those antennas, one of those Duncan, Oklahoma antennas, go ahead and snap it up. They're good antennas. That's all I have, folks, and I hope something I've said will help you and you won't have a headache with something.
What would be the difference in the antennas that you've shown compared to a portable antenna that you put up to a HF mobile or a GoKit?
Well, I'm glad you asked that. So actually, the difference again is compromise, trade-off. There are all kinds of mobile antennas in the notes that we were going to have. There are some notes in there about mobile antennas, particularly the OPEC HV 400. But they're all a compromise. Every mobile antenna for HF is a compromise, but I hear good reports by the screwdriver people. So if nobody else has any more questions, let's take a break for 10 minutes and come back and we'll do the propagation. Thank you.